Question 1. Dash is generally faster than dash and dash. A. First fit, best fit, worst fit. B. Best fit, first fit, worst fit. C. Worst fit, best fit, first fit. D. None of these. Your time starts now. 5, 4, 3, 2, 1. Answer: A. First fit, best fit, worst fit. First fit is generally faster than best fit and worst fit because it only needs to search the list of free memory blocks until it finds the first one that is large enough to accommodate the process. Best fit and worst fit, on the other hand, need to search the entire list of free memory blocks to find the smallest or largest block that is large enough to accommodate the process. This makes them slower than first fit. In addition, first fit is less likely to leave behind small, unused memory blocks than best fit or worst fit. This is because first fit will allocate a larger block of memory even if it is not the smallest block that is large enough to accommodate the process. This can help to improve memory utilization. However, first fit is not always the best choice for memory allocation. If it is important to minimize the amount of fragmentation, then best fit or worst fit may be better choices. Additionally, if the system is frequently allocating and deallocating memory, then first fit may not be the best choice because it can be slower than best fit or worst fit in these cases. Overall, first fit is a good choice for memory allocation when speed is important and fragmentation is not a major concern.
Question. Deadlock prevention is a set of methods. A. To ensure that at least one of the necessary conditions cannot hold. B. To ensure that all of the necessary conditions do not hold. C. To decide if the requested resources for a process have to be given or not. D. To recover from a deadlock. Your time starts now. 5, 4, 3, 2, 1. Answer: A. To ensure that at least one of the necessary conditions cannot hold. Explanation. Deadlock prevention is a set of methods that can be used to ensure that at least one of the 4 necessary conditions for deadlock cannot hold. These 4 conditions are: 1. Mutual exclusion. Each resource can be held by only one process at a time. 2. Hold and wait. A process that is holding resources can request additional resources. 3. No preemption. A resource can only be taken away from a process that is not using it. 4. Circular wait. A set of processes exists such that each process is waiting for a resource that is held by the next process in the set. By preventing one or more of these conditions from holding, deadlock can be avoided. Some common deadlock prevention methods include: resource allocation graph. A graph is used to represent the resource allocation state of the system. Each node in the graph represents a process, and each edge represents a resource that is being held by the process. The graph is checked to ensure that no cycle exists. If a cycle exists, then deadlock is possible. Priority-based allocation. Resources are allocated to processes in order of priority. A process with a higher priority can preempt a process with a lower priority if the higher priority process needs the resource. Allocation of all resources at once. All resources that a process needs are allocated to it before the process starts executing. This prevents the process from entering a hold and wait situation. Deadlock prevention is a reliable way to avoid deadlocks, but it can also be inefficient. For example, resource allocation graphs can be large and complex, and priority-based allocation can lead to starvation of low-priority processes. As a result, deadlock prevention is not always used in practice. Other approaches, such as deadlock detection and recovery, are often used instead. Thanks for watching. Please subscribe for more videos. Don't forget to like the video. Question. Cache memory works on the principle of A. Locality of data. B. Locality of memory. C. Locality of reference. D. Locality of reference and memory. Your time starts now. 5, 4, 3, 2, 1. Answer: C. Locality of reference. Explanation. Cache memory operates based on the principle of locality of reference. The locality of reference refers to the tendency of a program to access data or instructions that are close to each other in both time and space. Cache memory is a small and fast memory component located closer to the CPU compared to main memory. It is designed to store frequently accessed data and instructions, taking advantage of the principle of locality. There are two types of locality. 1. Temporal locality. This refers to the idea that if a particular memory location is accessed, it is likely to be accessed again in the near future. Cache memory exploits temporal locality by keeping recently accessed data in the cache, making it readily available for subsequent accesses. 2. Spatial locality. This implies that if a particular memory location is accessed, nearby memory locations are also likely to be accessed soon. Cache memory leverages spatial locality by fetching a block of data from main memory into the cache when a memory location is accessed. This anticipates that the program may need the adjacent data as well, reducing the latency of future memory accesses. By capitalizing on the principle of locality of reference, cache memory significantly improves overall system performance by reducing the average time it takes to access data from main memory. Thanks for watching. Please subscribe for more videos. Don't forget to like the video. Question. For effective operating system, when to check for deadlock? A. Every time a resource request is made. B. At fixed time intervals. C. Both A and B. D. None of the mentioned. Your time starts now. 5, 4, 3, 2, 1. Answer: C. Both A and B. Explanation. To effectively manage deadlocks in an operating system, it is necessary to check for deadlocks at multiple points in the system. The two commonly used approaches are: A. Every time a resource request is made. When a process requests a resource, the operating system can check if granting that resource will result in a deadlock. It can examine the current resource allocation state and determine if the requested resource will cause a circular wait condition or any other deadlock condition. B. At fixed time intervals, in addition to checking for deadlocks when a resource request is made, the operating system can periodically check the resource allocation state of the system at fixed time intervals. This allows for proactive deadlock detection, even if no immediate resource requests are being made. By periodically analyzing the resource allocation state, the operating system can identify potential deadlock situations and take appropriate actions to resolve or prevent them. By combining both approaches, an operating system can actively monitor and handle deadlocks in a more effective manner. Therefore, the correct answer is option C, both A and B. Thanks for watching. Please subscribe for more videos. Don't forget to like the video. Question. In priority scheduling algorithm, A. CPU is allocated to the process with highest priority. B. CPU is allocated to the process with lowest priority. C. Equal priority processes cannot be scheduled. D. None of the mentioned. Your time starts now. 5, 4, 3, 2, 1. The answer is A. CPU is allocated to the process with highest priority. In priority scheduling, the processes are assigned priorities. The process with the highest priority is given the CPU first. If there are two or more processes with the same priority, then they are scheduled on a first-come, first-served basis. So, the correct option is A. The other options are incorrect. Option B is incorrect because the CPU is allocated to the process with the highest priority, not the lowest priority. Option C is incorrect because equal priority processes can be scheduled. Option D is incorrect because one of the mentioned options are correct. Here is an example of priority scheduling. Process. Priority. Arrival time. P1. 10. 0. P2. 5. 0. P3. 1. 1. In this example, P1 would be scheduled first, followed by P2 and then P3. This is because P1 has the highest priority, followed by P2 and then P3. Thanks for watching. Please subscribe for more videos. Don't forget to like the video. Question. A process is selected, queue by the, scheduler, to be executed. A. Blocked, short term. B. Wait, long term. C. Ready, short term. D. Ready, long term. Your time starts now. 5, 4, 3, 2, 1. The answer is C. Ready, short term. The short-term scheduler selects a process from the ready queue to be executed. The ready queue is a list of all the processes that are ready to execute. The short-term scheduler is also known as the CPU scheduler. The blocked queue is a list of all the processes that are blocked, waiting for an event to occur. The wait queue is a list of all the processes that are waiting for I/O. The long-term scheduler selects processes from the job queue and puts them in the ready queue. So the answer is C, ready, short term. Thanks for watching. Please subscribe for more videos. Don't forget to like the video.
Question. The overall I/O rate in RAID level 4 is low, very low, high. None of these. Your time starts now. 5, 4, 3, 2, 1. Answer, C, high. In RAID level 4, the overall input-output, I/O, rate is typically high. RAID, redundant array of independent disks, level 4 uses block-level stripping with a dedicated parity disk. Data is distributed across multiple disks, and parity information is stored on a separate disk. With this configuration, RAID level 4 can achieve high data transfer rates during both read and write operations. The data can be accessed concurrently from multiple disks, which improves the overall I/O performance. The dedicated parity disk allows for fault tolerance and data recovery in case of a disk failure. Therefore, RAID level 4 is known for its higher I/O rates compared to other RAID levels such as RAID 1, mirroring, or RAID 5, block-level stripping with distributed parity. Question. In which of the RAID level, rebuilding the lost data is easiest? 1, 2, 3, 4. Your time starts now. 5, 4, 3, 2, 1. The answer is A, RAID 1. RAID 1 is a simple mirroring setup, which means that each data block is written to two separate disks. This provides excellent data redundancy and makes it very easy to rebuild lost data if a disk fails. RAID 2 is a bit more complex, as it uses a parity scheme to distribute data across multiple disks. This provides better performance than RAID 1, but it also makes it more difficult to rebuild lost data if a disk fails. RAID 3 and RAID 4 are both stripping schemes, which means that data is written across multiple disks in a sequential order. This provides good performance, but it also makes it more difficult to rebuild lost data if a disk fails. RAID 5 is a more advanced stripping scheme that uses parity to improve data redundancy. This makes it more difficult to rebuild lost data than RAID 1, but it still provides better performance than RAID 1. RAID 6 is the most advanced RAID level, as it uses two parity disks to improve data redundancy. This makes it the most difficult RAID level to rebuild lost data, but it also provides the best data protection. Therefore, the RAID level in which rebuilding the lost data is easiest is RAID 1. So the answer is A. Thanks for watching. Please subscribe for more videos. Don't forget to like the video. Question. Interrupts which are initiated by an instruction are internal, external, hardware, software. Your time starts now. 5, 4, 3, 2, 1. The answer is D, software. A software interrupt is an interrupt that is caused by executing a special instruction in the instruction set. This instruction is called an int instruction, and it tells the processor to interrupt the current program and execute a special interrupt handler. Software interrupts are used by the operating system to handle various events, such as system calls and error handling. They are also used by user programs to request services from the operating system. Internal interrupts are caused by events within the processor itself, such as an arithmetic overflow or a divide by zero error. External interrupts are caused by events outside the processor, such as a keyboard input or a hard drive access. Hardware interrupts are a type of interrupt that is caused by hardware devices. These devices can generate interrupts when they need to be serviced by the processor. Therefore, the interrupts which are initiated by an instruction are software interrupts. So the answer is D. Thanks for watching. Please subscribe for more videos. Don't forget to like the video. Question. RAID level 3 does not have dash as in RAID level 1. Efficiency. Enough storage space for data. Storage overhead. Time consumption overhead. Your time starts now. 5, 4, 3, 2, 1. The answer is C. Storage overhead. RAID level 1 uses mirroring, which means that each data block is written to two separate disks. This provides excellent data redundancy and makes it very easy to rebuild lost data if a disk fails. However, it also means that half of the storage space is wasted, as each data block is stored twice. RAID level 3 uses block level stripping with parity, which means that data is striped across multiple disks, with the parity block stored on a separate disk. This provides good data redundancy and performance, but it does not have the same storage overhead as RAID level 1. Therefore, RAID level 3 does not have storage overhead as in RAID level 1. So the answer is C. The other answer choices are incorrect. RAID level 3 does have efficiency, enough storage space for data, and time consumption overhead. Thanks for watching. Please subscribe for more videos. Don't forget to like the video. Question. Effective access time is directly proportional to page fault rate, hit ratio, memory access time. None of the mentioned. Your time starts now. 5, 4, 3, 2, 1. The answer is A. Page fault rate. Effective access time is directly proportional to the page fault rate. A page fault occurs when a requested page is not present in the main memory and needs to be fetched from secondary storage, such as a disk. Handling page faults introduces additional overhead, such as disk I/O and memory management operations, which can significantly impact the overall access time. When the page fault rate increases, it means that there is a higher frequency of page faults, resulting in longer access times. As a result, the effective access time increases. Thanks for watching. Please subscribe for more videos. Don't forget to like the video.